This computer. Okay, we'll wait another few minutes.
So when you officially start, you should probably warn everybody that is being recorded.
Well, already anyone who now enters the room will get a pop-up saying that the meeting is being recorded.
Okay.
So, and they have to agree to it in order to enter the room. Also, there's nothing here you're presenting. They're just possibly asking a question or two. So I don't go for all this permission stuff, you know, oh, you need permission to record that I'm on the Zoom. I assume you're in East Coast time currently. You're
and daylight savings time went away on Sunday.
right. Well, out of the 45, we only have currently about 10. But so let's wait a little bit more. I guess people in Israel are not prompt. We'll give it 2 minutes and then we'll start with whoever's here.
It's only 2 minutes past the hour and it takes people a while to get sorted out. I used to have a boss who would lock the door of the meeting room about a minute or two before the meeting started, and you had to knock on the door, and he got to decide whether he let you in or not. And if you were late, then he made you wear a dunce cap for the entire meeting.
I actually like that idea.
This inspired promptness.
Yes. Why not? Especially on this kind of aspect. I mean, it's not where you have to run from building to building or floor to floor. You just have to move your out mouse a little, and that doesn't require much.
Well, yes, although if you also have a problem of scheduled meetings one after the other with no breaks, then sometimes you have to give people a break.
Right. Okay. 1 more minute and then we will start it.
Okay.
How are you during this entire COVID-19 period?
Well, no travel. Well, I was about to say no travel. I've actually done 2 trips to the West Coast in the last month, and I'm going up to New York today and Connecticut, and then I'll be out in Malibu in December. So 4 trips in 18 months, roughly, which is different from the 80% travel schedule that I normally kept until March of 2020.
Which did you like better, travel or staying at home?
I'm actually, well, I don't think I'll ever go back to the 80% travel schedule. It's very tiring and it's very wasteful of time. I mean, it's huge overhead.
Yes.
So my reactions now tend to be of the form, you want to see me, come here, or we'll do a video call. I will still travel, but not nearly as much now that we've demonstrated that these kinds of meetings are feasible.
Mm-hmm. Okay.
You know, with the fake backgrounds caused very strange things to happen, like your arm was dangling in the image.
Yes, I know that.
And the rest of you had disappeared. You know, it's just like the Invisible Man stories.
Yes. Well, we're going to start because we're now 4 minutes over. Hopefully more people will be joining other than what we have currently. I'd like to introduce to everyone vintcerf, who I first met in 1992. If you didn't know, but this was at MIT. I don't know if as Vint was saying, this is the proceedings which was at MIT, where on stage, Vint was dressed in the same way with his 3-piece suit, white shirt, tie, and everything. And we had about 300 people in the crowd. and you're talking about the internet, and suddenly you started stripping. You took off your shirt, your jacket, your tie, and underneath you had the T-shirt that said "IP on everything," and the crowd
Yes,
went wild.
yes,
Um,
they did. In
so
fact,
remember that.
one guy ran up and stuck a $5 bill in my waistband, which I thought was pretty funny.
Right. Okay. But that was the first time I saw you, and I've run into you a few times in the past, and this is a brand new isoc chapter, which I know you're now trying to set up for interplanetary use. And so we're a fairly new chapter that we've been there, but we haven't been too active. And we now set up an IL-NOG similar to NANOG and similar to NL-NOG. And you are our second speaker. And so I've given you the introduction. I don't think anyone really needs to get too much introduction about you. You can look on Wikipedia, and
Right.
it's probably 15 minutes of reading. So I'll let you get started, and I will now share the presentation.
Thank you for that. Just for everybody's information, we tried to let me share the presentation, and while I could get the slides up, my microphone was muted automatically by your friendly Zoom system, and we didn't have time to go figure out how to debug that. There is a way to do it. I just didn't find it in time. So thanks to Hank for showing the slides for me. So first of all, the Interplanetary Network Special Interest Group was actually set up in 1998. It was the first SIG of isoc. And of course, in 92, when Hank and I met, I was then the founding president of the Internet Society. So this special interest group has been around for a long time. We have about 800 members now, scattered all around the world, and they're quite uniformly distributed among the continents, which is something that I find very satisfying. So I'm going to take you through a brief history of the internet, very, very brief, just to set the stage. And then we'll go into where we are with the solar system internet design. So yes, go ahead to the next slide, Hank. So some of you will have either were around or might have read about this particular demonstration. It was a 3-network system, all funded by the Defense Advanced Research Projects Agency. I was the project manager at the time in Washington, and the whole idea here was to demonstrate the TCP/IP protocols in a 3-network system, a mobile radio net, a packet satellite net, and the original ARPANET. What's important about this is that the parameters of each of those networks were dramatically different. The mobile radio net, of course, had lossy connectivity. The satellite network had high latency, and the ARPANET had low data rate, so like 50 kilobits a second in the backbone. So we made all 3 of those networks interwork with each other successfully in 1977. If you go to the next slide, skipping forward to the present, this actually was produced in 1999, so I'm cheating a little bit. It was built using the Border Gateway Protocol forwarding tables. And so each color represents a different network. And as all of you must know, they all choose what hardware and software they're going to apply. They decide who to connect with and on what terms and conditions. It's all very decentralized. Except for the fact that ICANN, the Internet Corporation for Assigned Names and Numbers, allocates IP addresses and domain names in a unique fashion so that we don't allocate these same IDs to 2 people or 2 organizations. Of course, it's also the case that there's been concentration to some degree in the evolution of the internet in terms of what networks are, major networks exist. There's a lot of undersea cable that's gone into the system. But nonetheless, this is a global network, which is touched by about half of the world's population. And we continue as isoc to work on getting the other half of the world up and running. Let's go to the next slide. So back in 1997, the Pathfinder mission was mounted a successful landing on Mars with a small rover. And this triggered a great deal of excitement because for 20 years before that, nothing worked. We had the Viking landers in 76, 2 of them, and then failure for 20 years, and then the successful landing of the Pathfinder. And so I went to the Jet Propulsion Laboratory to meet with the communications team. that was supporting the Pathfinder project, and we concluded that we were asking ourselves, what should we be doing now, that is to say in 1998, to be prepared for what would be needed 25 years later. And we decided that building an interplanetary backbone was in fact a good target to supplant the heretofore point-to-point radio links, which were the only thing available for space exploration. So if you go to the next slide, I think you'll just see a few of the, you'll see several of the robots that have successfully landed on Mars, including Spirit and Opportunity and Sojourner in '97 as part of the Pathfinder project, and Curiosity in 2012. In fact, if you go to the next slide, I think we'll see some more of the landed. There's quite a large number of instruments have been successfully landed on Mars, and now there are other countries, China, for example, and India, and Europe, that are putting either things in orbit or successfully landing things on the surface. So let's go to the next slide. When when we started this work, we were out at JPL and eventually accumulated folks from MITRE, Goddard, and the Applied Physics Laboratory. And so this is a relatively small team. We then had to the two Spirit and Opportunity robots landed on Mars. The original plan was to transmit data back from the surface of Mars to the Deep Space Network. These are the three big 70-meter dishes in Canberra, Australia, Madrid, Spain, and Goldstone, California. But the radios overheated, and the engineers reduced the duty cycle, which made it for a lot of grumpy scientists because they were already unhappy with the wimpy bandwidth that was available from the surface. But it turned out that there was an X-band radio on board both of the rovers, Spirit and Opportunity, and the orbiters, the Mars Express and the Mars Reconnaissance orbiters, both had X-band radios, and those orbiters have been sent to map the surface of Mars in order to decide where to send the rovers. So we reprogrammed both the orbiters and the two Spirit and Opportunity rovers to transmit data up to the orbiters, and then the orbiters would hold that data till they got to the right place in their orbit to transmit data back to the Deep Space Network. What was interesting is that the orbiters were near the rovers. They're more than a few hundred miles away, and so we could transmit data at 128 kilobits a second on the X-band radio. And because the orbiters were outside of the atmosphere and had larger solar antennas or solar power, they could transmit data to the Deep Space Net at 128 kilobits a second. So this store and forward network delivered 4 times as much data as the original design plan. We were using, and still have been using since 2004, a largely manual file transfer process. So the ground people on Earth are controlling when things get transmitted, either up to the orbiter or from the orbiter to the Deep Space Net. But we started developing a more automated system to accomplish the same task. So let's go to the next slide. So when we started, we thought we could use TCP/IP because it worked on Earth, so we thought it ought to work on Mars. But when you do the math, you discover the distance between the planets is literally astronomical. And the round trip times could be as much as 40 minutes. And so TCP flow control doesn't work very well with that kind of a round trip time. There's also disruption because the planets are rotating and you can't talk to something on the ground if it's, if the planet's in between you and its antennas. And DNS lookup doesn't work very well either because, you're on Mars, you're trying to find a destination on Earth, you do a lookup, 40 minutes later, maybe you get an IP address back, except by that time, the target has already moved to a different location on a different radio link. And so now it's got a different IP address. So we evolved the notion of delay and disruption tolerant networking and developed a whole new suite of protocols we call the bundle protocol suite, which has a number of interesting properties. One of them is that the name resolution is done in 2 steps. First, get to the planet you're going to, and then do the resolution to find out where the target actually is. Second, we store information in the network. So if you were on your way to Jupiter and you stopped it at an intermediate node on Mars, for example, and did not have an active link to Jupiter yet because of celestial motion, instead of throwing the data away, which is what we would do with TCP/IP, we hold the data in the network until the link comes up based on the contact graph that we've calculated for when connectivity is anticipated. We also had to redefine network management because ping is not your friend in this environment. Normally, you send a ping packet, you expect to get something back in a half a second or less. But in this DTN environment, it could be days, hours to days, with a lot of uncertainty in a multi-hop environment. And finally, one of the things I insisted on is that we include strong authentication and encryption among the nodes of the interplanetary backbone, because I didn't want a big headline saying 15-year-old takes over MarsNet. So those are all components of the bundle protocol and related protocols in the suite. Let's go to the next slide. Now, I'm not going to march through every one of these things, but the thing I want to leave you with is an understanding that we have done extensive testing and evolution of the bundle protocols. We're now at bundle protocol version 7, which we are standardizing both in the Internet Engineering Task Force and the Consultative Committee on Space Data Systems, which is made up of all the spacefaring nations. Those bundle protocols are in operation on the International Space Station. But we did testing in space because we got permission to use spacecraft like Epoxy that had already visited 2 comets, and they said they completed their primary missions. It's okay for us to upload new software in order to test the protocols in deep space. We've used the International Space Station since 2009 to test and use the protocols. Folks on board, the astronauts on board the International Space Station, are primarily using it for personal communications and for experimental support for experiments that are in the space station. We're not using it for control of the space station itself. That's a different set of protocols. But eventually, as you'll see, the bundle protocols will end up being the primary support for space communications, at least as far as we can see. We've had very good cooperation with the European Space Agency. They were able to demonstrate that the bundle protocols, although they've been designed to deal with very high latencies, were also suitable for real-time communication if, in fact, the distances were short. So from the International Space Station, there isn't very much distance to Earth, and so they showed that an astronaut could steer a robot in real time, which you couldn't do between Earth and Mars, obviously, but you could do if you were in orbit around Mars and directly interacting with a Mars-based robot. We also wanted to test a high-speed mode, and so we used the Lunar laser communications demonstration using an optical laser to the spacecraft in orbit around the moon. We were able to transmit data at 622 megabits a second. And that satisfied 2 things. We wanted to show that the protocols work in a highly delayed and disrupted environment, but also work for real-time control and also for high speed. Next slide. So there have been continuing tests and validations of the protocols, including evolution from version 6 to version 7, and from the Licklider Transport Protocol version 1 to Licklider Transport Protocol version 2, or Transmission Protocol version 2. LTP is basically a link level protocol for point-to-point links, and then of course bundle protocol is for a multi-hop system. We even have seen some tests of the concept of DTN in the north of Sweden. We're teaming with a group at Luleå who've implemented DTN protocols to track the Sami reindeer that are up in the northern part of Sweden. They're wearing small little transceivers that localize where they are, and they'll transmit data through the store and forward system in order to keep using the DTN concept. So that's an unusual application. Next slide. We have some implementations for other equipment, the IBR DTN implementation for small devices or for Android operating systems. NASA, ESA, JAXA, the Japanese Space Agency, and the Korean Space Agency are all involved in deployment activities using the bundle protocols. We put NASA's version, which is the ION implementation of the bundle protocol, on the Google Cloud, on the Azure Cloud, and on the AWS Cloud in anticipation of running some terrestrial tests at scale. Some of you will remember the SETI at home, remember the search for extraterrestrial intelligence. They were receiving radio transmission data, and they were sharing it with the general public who were running an application in their laptops in order to analyze the received radio signals to see if there was any regularity in them. And so we're thinking about solar system internet at home, where we would have people running the bundle protocols in their laptops or mobiles, exercising the system at scale in order to allow us to test our network management technology and also to verify that this system operates well with large numbers of nodes. We are moving the data from SourceForge to GitLab. I'm not sure whether that's done yet. And both the ION implementation and the University of Braunschweig implementations are available there. We are in the process of working with the various space agencies, especially NASA, in preparation for the return to the moon. The Artemis and the Gateway missions are scheduled to use the bundle protocols. And of course, we anticipate their use when the Mars missions are mounted in the 2030s. If you're interested in tracking all this stuff, if you go to ipnsig.org, you'll see whatever our updates are, and you'll see opportunities for participating in some of the activities that would help us make the protocols implementations as resilient as possible. I think there's a couple more slides to go. This is our logo for the IPN SIG. If you want to go to the next slide. We have 800 members, as I said before, and you can see they're pretty nicely distributed around the world. Next slide. So here's our vision, is to expand networking into interplanetary space for everyone's benefit. Next slide. There are a bunch of working groups that any of you might be interested in participating in. The strategy working group published a report, which I'll get to in just a second, in June of this year, describing our expectation of the evolution of a backbone network over the course of the next 100 years. There are some near-term projects that Oscar Garcia is leading in the pilot working group effort, which involves local testing, terrestrial testing, for example. There's an outreach working group, which is to try to draw people's attention to the whole idea of an interplanetary backbone network. Documentation about the bundle protocols is being accumulated in a library that will be maintained by IPN SIG. There's questions about what happens when you actually build an interplanetary backbone. How does it actually function, and how is it governed? Especially if you imagine over time that there will be both commercial, government, and private sector interests in its operation. So figuring out how to make that work is at least as complicated as getting the internet to work on a global scale. And then finally, business ideas to promote the use of space and space communications for commercial purposes is another possible working group. Next slide. Here are some of the experiments that are currently underway within the project working group. These slides will be available, and this whole thing is being recorded, so I'm not going to walk my way through all of these, except to invite you to look at those and come to the website at ipnsig.org and consider engaging with some of these projects of interest. Next slide. This is the report that I mentioned. You'll find it on the website. It's actually a fairly brief report. It's 50 pages long, but a lot of it's pictures. But I hope you'll get a sense for what we intend to explore, which is, how could you actually build and operate an interplanetary backbone network, accumulating experience and growing it over the course of a 100-year period. Next slide. So this is kind of our going in imagining, not unlike the way the internet started. It started out, as you will remember, as government-sponsored networks for research, and then we started seeing both commercial operation and academic operation in addition to the original government sponsors. And eventually, though, we anticipate that 100 years from now, the bulk of the network will be operated as a commercial system to support the exploitation of space for commercial purposes, while still having possibly some disconnected government and academic networks that are still supporting research. Next slide. So the last point I want to make is that since we think we know what we're doing in the solar system, we think we can convincingly demonstrate it's possible to implement all this. We started asking ourselves, well, what about mounting a mission to Alpha Centauri? The first problem is that current propulsion, it would take 76,000 years to get there, which is kind of a long time for an experiment. Second, there's a navigation issue because mid-course correction becomes a little problematic when you're 1 light year. Remember, Alpha Centauri is 4 light years away, 4.3 light years away. And so if you're 1 light year away, it takes a year for your signal to get there and another year to come back, which is not exactly interactive when you're trying to do mid-course corrections. So we anticipate that there'll have to be onboard navigation, possibly using pulsars, both in this galaxy and in other galaxies, which won't shift in terms of location or apparent location much over even 100-year period and over a 4.3 light year distance. So those could be possibly used for navigational purposes. And then the last problem is how in the hell do you signal data over a 4.3 light year distance? And one of the most notable problems is that if you're in orbit around Alpha Centauri or Proxima Centauri, and you want to transmit data back, let's assume you're using a laser. Let's assume that the light of the sun is not in line with the antenna, otherwise it's blinded. The receiver on Earth would be blinded. The problem is you have to figure out where to point the beam to intersect Earth 4.3 years later after you transmitted the data. And that's a really interesting computational problem, is where do you aim the laser? So the next slide tells you what we did to find out. I went to Lincoln Laboratory, which is part of MIT, as you know, and we said, can you help us understand what the challenges are in this Alpha Centauri mission? And they came back a couple months later with a fairly complete report of what the challenges are. And there's an hour's worth of presentation at this URL. Basically, they said we're 53 dB away from being able to mount a mission like that. So we have a lot of work to do before the Alpha Centauri idea gets any legs. I think that's the last slide. Let's see what happens when you click it again. Nothing happens. Okay, so we can go back now, Hank, to Q&A if anybody has questions, and I'll bring up the chat just in case somebody wants to use that for a question. So I hope this gives you a little taste of what we're doing. IPN-SIG is happy to have additional members, and so feel free to join us.
Anyone have questions for Vint? Feel free to unmute and ask. It's quite an interesting topic, something that I had no idea was existing or being developed, and I'm sure everyone here was enlightened by what you have said, but I don't want to talk too much in case someone wants to ask any questions.
Well, I have one. I don't know whether anybody here is interested in the problem, but do you have any, as you think about this, one thing that would be useful would be thinking more about the network management side of things. We have APL has taken the lead on network management and security, and we're concerned about both of those. And the harder problem, in my view, is not the protocol suite, but it's figuring out how multiple entities will be able to work together to operate an interplanetary backbone. In the internet case, we were able to allow different organizations to build their own pieces of the internet and then interconnect with each other however they wanted to. And because the protocols essentially supported that notion of multiple networks, it was possible to actually operate in this relatively distributed way. We imagine we may have to do something similar to that in the interplanetary backbone to allow multiple agencies to control their own assets, but still be able to offer in some mutual way access to shared resources in order to support the backbone network. We're still not quite sure what the implementation path is going to look like. It could be, one possibility is that people simply contribute nodes to a single backbone network at the beginning, which is sort of like the ARPANET. And then later, as people have invested in more space communications assets, they might actually bifurcate into multiple networks. So we do have an inter-region architecture and protocol for the bundle protocol system, and we'll be testing it this year and next year to see whether or not it performs the way we would expect it to.
Has anyone from Israel been involved with your SIG?
So the answer is I don't know. Not that I am aware of, but that doesn't mean there isn't a member, an isoc member who's already engaged. I don't have a list of names. I just have the numbers, and they're aggregated, as you could see from that chart, into different regions.
Okay. I will try to somehow contact someone at the Israel Space Agency and see if they're interested.
Wonderful.
See if they're interested, although they're probably more focused on the next 3 years plan rather than the next 100-year plan.
Well, still, if you're thinking about exploration of the moon or Mars, you have to be thinking 10 years out, generally speaking. So I would hope that the Israeli Space Agency is participant in CCSDS, for example. And if they are, then in theory, they should be well informed about the current state of the protocol, since CCSDS is, along with the IETF, the standardizing agency. Incidentally, everybody here, I'm sure, is familiar with IANA, the Internet Assigned Numbers Authority, which operates as part of ICANN. There is an equivalent of that in CCSDS called SANA, which is the space, whatever.
Assigned Number Authority.
Assigned Numbers Authority, right, thank you. So there's already just, tiny little bits of potential institutional focus for the longer term.
Okay.
Like somebody's mobile phone just went off. It must be mine.
Yes.
Sorry about that.
That's okay. Can I share your slides with the group, with our IL-NOG group?
Absolutely. I have no problem with that. It's all open stuff.
Okay. Anyone have any questions before we finish the Zoom meeting? Okay, I'd like to thank Vint for his time. Early Monday morning, East Coast time. And I hope one day that we'll be able to see you here in Israel, maybe.
Well, I would like to return. It's been a long time since I have had a chance to come to Tel Aviv or any of the other. But the last time I was there, I think I was in Eilat, and it was a meeting of about a couple of hundred entrepreneurs. And we had a really good time talking about internet entrepreneurship. In fact, the guy that did Waze is an Israeli, and if I remember correctly, and we bought his company, so he was very happy about that. But he explained to the entrepreneurs that were gathered that he'd started 4 other companies that didn't work out, and so they should give up. That failure is not fatal, and they should just try again.
Yes. Yes, we're all familiar here with Waze, and we know about its algorithms and its problems post-COVID-19. And hopefully one day they'll resolve their algorithms, their problems.
I hope so. I hope
Yeah.
so. Well, thanks for giving me an opportunity to tell you where we are on the Interplanetary Network.
Okay.
Hopefully some of you will consider participating.
Absolutely. Have a good day, Vint. Thank you, everyone, for participating, and everyone have a good day. Bye.
Thank
Thank you very much.
Very much.